What is PCG and why should you care? PCG will be the way we populate most of the art assets in the world. PCG stands for Procedural Content Generation, but I don't think it deserves that title just yet in 5.3, because all it can do is just copy existing assets to specified locations in the world. But it can do that very efficiently, and that's very powerful. If you want to modify assets, however, you need to use geometry script, and that can be very slow at runtime. In this video, I will show you how to use PCG for architectural design and how can you make your own custom nodes using blueprint elements so you can expand your graph logic beyond the available nodes. There are many ways to achieve the same result, so don't get stuck using my methods. Explore, come up with new ways, and then show me. I'd love to see it. First thing, enable these plugins. Second, let's make a PCG graph. Just keep it as new graph and open that. Okay. So that's what you get here, input, output. You don't really need to use them. You could output a static mesh like that, and then whatever points go in here, and then you will see your static mesh. We'll try to get one here, mesh entries, there, description, and there you can get any static mesh you need. Okay. So what is all of this? The stuff on this side are the nodes and operations and everything you need. You could just get and drag from here. And down here you get more data if you press A and D on the thing, or E to disable, or A and D. You can see the information here, and also in the level we'll be able to see representation, or like a point in space for the thing we just selected. I made another graph here, and I put all of these nodes in here just to see what they are and what do they do. And I've noticed one thing, the ones that are in blue like that can be opened. So you can double click on, let's say, this one, and you can see the insides of this node. And it mainly has two things here, the execute with context and the iteration loop body. It's a lot of nodes, and trying to understand this from the get-go is pretty difficult, so I'll get back to this in a second. But for now, we'll focus on here. That's the PCG graph where you will do everything in here. And if you need an extra functionality that doesn't exist, you can make one of these blue elements, like PCG blueprint elements. You can make them and like do all the logic in here and use them as part of your graph. But for now, let's just use the existing ones. So I'll put down a grid of points. I delete this one, I don't need it. And I will visualize this. You will not be able to see anything and no debug because this thing is not in the scene just yet. So once I have it in the scene, I can see it up here, and then I can look down here and see the points, which I don't have any. at the moment. So why is that? Well, let's see. Not gonna change if I put the output, but if I do this, still nothing. Generate, clean up, generate, nothing. So what's the problem? Looks like maybe I need local like that, and this might crash. No, we're good. So we got this now. I'll disable that and I'll see it and just the, well, okay. So there's something going on here. Oh, it's just they're too tiny. So I could either go to the debug here and then do absolute and then do like 5. Maybe it's too big, but yeah. This, now the points are just intersecting because they're just too big. But if I expand the extent, so I'll just do that here and just see, okay, still too big, but I'll go here and put it back to 1.5. There. Okay. So all of these points, we can copy other assets, static meshes to them, which is this thing. But this thing is also a box, but if we try to find another asset, you could see, okay. And now you can see how each one of these columns is copied to one of those. I'll try to do less. So the cell size is 100. If I do 200, it'll add a point every 200 step. So we can see how now we can instance so many assets with just a few steps here. Okay. So what's going on here? I try to move it, but then the points are somewhere else. What I usually do is I get the actor data and I only use single point so that you don't explode the, trust me, just use single point for now. And then copy, so we'll copy all these grid of points to that one point, which is the actor itself. So the target there and there. So I'll just, and you can alt and to remove the wire. So just do that here. And then where did it go? All the way over here. This might be because I put local on here, so I'll uncheck that. Oh, that's not the case. Local inverse transform? Okay. So this grid of points just needs those two to work as expected. If we look at the scale, it's by default is 25, 25, 10, which we can just make 1, 1, 1. Do this. Okay. We're still seeing the points, but all the way at the center over there, and the columns are here. So if I remove the debug view from here, and then now they're gone from that side, and I'm only seeing this. If I debug this, for example, I might see them here. Yeah, they're under. So, okay. So the graph flows, the logic flows from the left to the right. This is the end. So the end goal here is to create a building like this with multiple layers and columns, and so I'll make a schematic design with the PCG points and then copy the static meshes to those points. So looking at this image, I need something to copy to something like a line here. So we have the columns, each of the columns would be copied to a line, and then same in the y direction. So here and there. So we'll make a line. The grid points could be used. It's hard to use though. I tried using it. I have to figure out what's the cell size or grid extent, and like 2000 here, 100. It's just, I just need 10 points and that's it. And then they shift on the x-axis this much. So this is what we'll try to create now. There are other nodes that we might be able to use, like the transform, this node, but again, it has a minimum and a maximum offset. I think this might be random, I'm not sure, but every time I try to use it, it gives me unexpected results. I just need a transform node that just moves things by 300 units, and that's it. So I'll make that one as well. So let's start with how do I make one of these? Well, we can try to go here and right click, go to blueprint class, PCG element, and go this route, like here, and just create it. But the way I like to do it is find one of the existing ones, because they already have most of the stuff that work. So let's use the create points grid. I'll double click on that. This is the one. I'll go to it, and then I'll copy that, and I'll just place it somewhere here. Okay, I'll rename it to create line _2. Okay, open that, and now I have this execute with context, which we don't need everything in here, like the scale extent we don't really need. So I'm just gonna delete that, delete this, connect this here. Let's see, I don't need the increment. This is part of the scale extent. None of this. No. So this is the how many points we'll create. So I'll just promote this to a variable, and I'll just call it iteration or number, point number. There, compile, and I'll just do 5 by default. So in the iteration loop body, we can loop over each iteration and create a point, and we can see at the end here, make PCG point. That's the one that will make a point, and it'll make it based on this transform. So they are using this and a bunch of other things here to create the transform they need. So I almost don't need any of this, except I'll just keep one of the return nodes and one of these. So I'll just delete everything else. Okay, I'll get this here. Okay, that goes into the output. And here I'll only use the transform. Plug that in here. Okay, so based on each iteration, something will happen. So what I'm planning to do is I'll move on the x-axis, let's say by 100 units for each iteration. So I'll take this part here and I'll multiply by let's do 100. I want this to be float. Okay, I'll split the pin here and do X. So each iteration will be, let's say the first one is 0, second is 1, 2, 3, and each one will be multiplied by 100 and then plugged into the x-axis. And hopefully this will shift the points on the x-axis. So let's try it. First, the node customization, I'll just say create line 2. This is the name of the node. That's the way we will be able to see it in here. Okay. So I'll do this here instead. And it looks like it created 5 points, like we told it to, but okay, let's see how it looks in the level. And they're next to each other by 100 points, 100 units. So I'll go back in here. 100 is not enough. I'll do 300. Compile, save, go here. Yeah, that works. And okay, what if I wanted to change it later? I don't want to go back every time and edit that blueprint element, because if I'm using it in multiple PCG graphs, each graph needs to change this distance separately, and I cannot go back to the element itself and change it so that, because all the other graphs would change. So we'll expose that parameter in the element, and then we'll be able to change it separately in each graph. So I'll go into the element again, and all I would do here is just promote this to a variable. Let's say x-axis. Naming convention is horrible, but you can take care of that. Okay, so now we can see that we still have all the other variables from the points grid. So I'll delete. I don't need this. No. Cell size, no. Increments, no. Okay, hopefully it doesn't break. Yeah, still good. I don't need this anymore. Okay, so we can see that we have the x-axis here, and I can create an attribute. Create. Okay, so we'll put this to, let's say, integer. Put that here. Tell you what, I'll use float, and I'll also turn this into a float. So I'll start with the float first, do that here, then this here. It's better to multiply things by floats instead of, I don't know, this is an integer. Maybe we need decimals, so just in case. So I'll turn this into a float. Yeah, change it. Okay, this goes there. Compile, save, still does it? No. Oh, because this is 0. So it's taking, now it's taking the value from here, and I'll just do 300. So it's back where it's supposed to be. I could do 600. Okay, that works. So with this, this is an attribute inside this graph that is changing this PCG blueprint element from this graph. But what if I want to instance this graph and like just make another one of it, like here? So just copy it and paste it. Now I have two PCG graphs, but I want to the first one I want it to be 300 and the second 600. And you might have noticed that this did not change immediately. Usually you have to sometimes either move it or clean up and generate again to see it. But the original one would update immediately once you do something in the graph. Okay, so now what if I want this to be different than this one? Well, we need to expose that this parameter somewhere here so I can edit that. So what I could do is I could go into the graph settings and create a float parameter. Let's do 300 here, and I'll rename this to x-axis. Then I'll say get x-axis. Now I have that parameter. I'll plug that in here, and it still works as it's supposed to. But if I check that here and do 500 here, this would change, but the other one would not, unless I also go into the actor. Okay, let's see. Maybe I need to clean up and generate again, because I do not see the parameter override. Okay, so I don't see the parameter override. This is one of those little bugs. Okay, what if I did this? 300. Okay, now it works. Okay, maybe Epic should fix that. You have to instance the first one again to see the parameter you just exposed, which is weird. This should just work as it's supposed to. There is another way to create one of these attributes, those parameters, but that goes through a blueprint. Let's say this graph was inside another blueprint. You can use the get actor property, and then the property name or property attribute name, I forget which one, as long as you match the name of this parameter to the parameter inside the blueprint the PCG graph lives in, then this will take that information from the blueprint and pass it inside the PCG graph, which we don't really need to do here because Epic just made it easier to create parameters inside the graph itself. We don't really have to go through a blueprint so that I can change these parameters. But apparently there's still some like little glitches here where it doesn't show up unless I instance it, which is fine for now. So, but in this case, I don't want them to be separate. Like here, like every time I need a row of columns, I'll make another copy of it. It's just inconvenient. I want all of this to be as part of the same graph. So what I will do is I'll just delete the second one, keep using this one, and what I could do is I can use that create line, copy paste it. Let's say this goes here, but I want to transform it now. I want to move it this way. So I can either add a transform operation inside the create line itself, or I can make another blueprint element that transforms the previous ones. I think I'd prefer them to be separate. So I'll make another one, but this time we have already existing points. Before, we were relying on an iteration loop body, which was iterating over the point numbers we created and creating a point from those iterations. But now we already have points, so we will be looping over existing points. So this will be a different type of blueprint element. Okay, I need to delete that. Okay, you could see how there's execute, nested loop body, and now we were using the iteration loop body, but to loop over points, we need the point loop body. And the execute with context will look different when using the point loop body. And same like we did here, we copied it from the create points grid. We will find another blueprint element that is similar to what we need, and then copy it and make another point loop body for the transform node. Okay, so an easy node to use would be rebuild point rotation from normal. This is very similar to or very bare bones, so we can copy it. So the execute with context is exactly what we need. And the point loop body will just delete this stuff and change it to whatever we want. So first, before I destroy this node, and it's very useful, so instead of destroying it, I will copy it and do the same thing. Paste it here. And I'll do transform. Preferably do something like write like, I don't know, E underscore or PCG E underscore, just so that you know what it is. Okay, I'll open that, and I'll go into the point loop body. That's the only thing we need to change. Oh, node customization. Instead of this whole thing, will be like, I'll just do transform 2. Okay, point loop body. I want to change the transform, which is happening here, but not like this. No, what was that? Up vector? No, we don't need that. Break transform, yeah. I don't need all of this, only the transform. So just break the transform and edit the transform, make transform, goes into the member of the PCG point in the output. So first off, I'm just gonna compile and just make sure it works. So I get that and go to the graph. I'll put that here, transform 2, I don't need this anymore. So this goes here, and I will replace it with this for now. Okay. Okay. So nothing has changed. So if I do this here, it's still the same thing. Nothing has changed because this transform is doing nothing. So location is staying the same, rotation is staying the same, scale is the same. Okay, what if I just I'll add 300 on the z-axis just for fun. Compile, save. See how that got raised by 300. So let's see the difference. There you go. So now we can transform the nodes exactly as much as we need. So what we'll do is we'll do the same thing we did here. We'll expose some variables and create parameters to change those variables. So I'll go back in the transform, and what I will do is promote to variable, add position. Okay, compile, save, and I'll keep it at 0 just by default. This is create line 2. I'll close it for now. Okay, so we go back in here. So we can see how we have add position here. I'll bring this, and let's say I want to add, well, now it's set to float, but it's a vector that we're changing. So I'll go with this here, 0, 0, 0. So I'll go by 600 here. Okay. So now the difference between the first one and the second one is this transform, which is transformed 600 units on the y-axis. But I want them both. I want to see them both in here. So what I will do is I'll merge them. Merge this and that together here. Okay, now I can see them both. And I think I need double that distance. Something like that. Okay. Cool. Sometimes you need a union node after that. There's some intersections, or this just fixes things, but this graph can work without it for now, so I'll just disable it. Cool. Now the x-axis works. If I go in here, do 600 or 300. Okay, but what if I also want to change the point number? So how many columns I need? Same thing, we go in here and add, we did integer for that, rename column number. I'll put that to 5. Okay, get column number. That goes into point number here and there. Save that. Okay, 7. There we go. 12. Nice. Okay, we're getting somewhere. Now, as we saw in the picture, there's this part down here, there's that here, and then there's the roof. So there's a few elements that we need, some under, some above, and some at the top. First thing I'll do is get the module that sits at the bottom and shift the columns to be sitting on top. I'll get the graph again. So let's get the other one. Go to this, find, that's the one at the bottom, and I'll place it in here. So let's just see this one. Okay. Okay, so we want to move. Now you could see how the column is intersecting. It's inside the geometry sitting underneath. So I'll need to move up the columns. So I could do this in a few different ways. I could either use the transform and place that here. That goes there. Okay.
and then add, I don't know, maybe 300. Nope, 100, 120. Okay, looks like it's 100 units. So this kind of works. But what if I replaced the asset at the bottom? What would happen if it's slightly longer or shorter? We will have either gaps or intersection. A more modular way to do this would be by using mesh sockets. So I can get the socket of this mesh underneath. So I can place that here, and I can open this, go into the mesh, go to the details. Next to it there's a socket manager, and there's this plus button here. I create a socket and I'll place it where I want the column to sit. So this socket will turn into a point. I'll give it a tag. I'll just do A here. Then in here, put the mesh A. Okay, so now we have this as this point that sits at 100 units because of this here. If I go above like that, you could see how this is turning into 150, 200, etc. Okay, go back to 100. So this mesh socket will give me 100 units because this socket is sitting at the 100 units on the z-axis. So what I could do is use that to, instead of this transform that I had to input myself, I had to write that 100. But if later I change this asset, it can update with the mesh, with the socket and its height, and automatically just move the columns exactly where they're supposed to. So this is just another way to make things more procedural. So what we could do is copy points. This goes to the source, target here, and that goes there. So nothing has changed, and we can see that if I go in here and up the socket, see how everything changes. Yep. Okay. So there's those two ways, either with the transform or the more procedural way of using sockets. Okay, now we have the bottom, the column, and same thing, we need the piece that goes on top, which is this part. I'll just put that in here. Okay, so now we need to do the same thing. We need to move this all the way up above the column, but now it's sitting above this 100 unit here, and we need to do the same thing. Copy this again, but now instead of this, I'll find the column, and let's see where the mesh socket on the column is. It's all the way up here. Socket B, B. Okay, the tag is B. Instead of A, I'll just do B. And you could name this whatever, you don't have to follow these letters. And this goes here. Okay, so now we have the bottom, the column, top. One thing that is wrong here is this part is intersecting with the column. So I need this to have the height of the first one and the height of the column and added on top of each other. So instead of going directly from here to here, we go through the bottom piece and then the column. So we can see that here, this goes into there, and now it's fixed. Okay, let's add the roof. I'll get the roof piece, put that here, and let's see where this goes. I'll just do that first. Okay. So, of course, it's not where we need it, and it's being copied on both sides as if it's part of the column that, and that's not what we need. We just need one of them, and we need that to be in the center and rotated this way. Okay, first let's get the height right. So I'll get the same thing we did here, but for the top piece, I'll put that here, and let's see where the socket is, and the name of the socket, C. The tag is C, so this will be C. Then this goes there, and that goes. Okay, so now the roof is the correct height, but the problem is it's being instanced the same way like the columns. Also, it's the wrong orientation, and we have it being copied on both sides, which we don't need. So what I could do is, maybe I could just take this, put that here, that goes here. Also, I always need to be at the actor data position. Okay, let's see what this results in. Okay, just one side, the side of the original line. Okay, I need them rotated and then transformed a little bit to be in the center. So maybe I could use the transform node. Transform. First, save that. Oh no. If you double click this node, you will open Visual Studio. Yeah. Let's add rotation. So combine rotator and goes into rotation. Okay, that works. Let's try it. If I do 90, there we go. Okay, now all I need is to shift to this side. Okay, so the amount I moved here is 1,200. If I do a math operation here and move by half for the roof, so I can do that here, then multiply by float 0.5, so I'll multiply by half and then move that distance all the way up. Okay, expand this, get the add position, goes in here. There we go, we move by half. Okay, so let's say I move by 1800. I mean, that looks maybe 2100. Okay, this looks like something. Save that. Okay, so that's the whole graph. this can be turned into another graph parameter here. I know this kind of looks ugly here because we copied it again, but it is what it is. It works. It could be cleaner. Another challenge would be making the corner points and then copying this and rotating the create line to this side and then also on that side. Yep. Go here like that. Okay. This is with the corner points, and it also has a way to add more or less. But you can see how we can create that with just adding a line and copying points, then also using sockets to know how far we need to move up. The corner points, I used another PCG element just to create corners. It's very simple. We can take a look at it. It's using the iteration loop body, which we did earlier. If you remember, with the create line, we used iteration loop body to make a line. I did the same thing with the corners, and I created an array of 4 points. Each point has a location and a rotation. Yeah, just don't double click random nodes. You will open Visual Studio. Okay, this video is getting too long. I'll cover the books and the stacking of cubes and boxes and making circles, all of this stuff in the next video. So stay tuned.